deals with the effective concentration on cell EMF, or cell voltage. We know from last chapter that delta G is equal to delta G naught plus the natural log of Q times R times T, where again Q is the reaction quotient. Delta G, we found out in the previous video that delta G was equal to negative NFE, but we also found out that delta G naught is equal to minus NFE naught. So if I were to take the delta G and replace it with negative NFE and the delta G naught and replace it with negative NFE naught, I would get an equation that looks like this. If I solve this equation for E, I get another equation which is called the Nernst equation, which looks like this. It's saying that E naught is equal to E naught of the cell minus R times T over N times F times the natural log of Q, which again is the reaction quotient. And remember, the reaction quotient will be the concentrations or pressures of the products over the concentrations or pressures of the reactants. At 298 Kelvin, if we set the temperature to 298 Kelvin, keeping the temperature constant at 298 Kelvin, since R is a constant and F is also a constant, we get an equation that looks like this. Now remember, this equation is only true if the temperature remains constant at 298 Kelvin. If it does not, you would have to refer back to the former equation to solve any problems that you might encounter. If you don't like the natural log version, well, there's a base 10 log version as well. So let's take a look at this particular situation in which we have Fe2 plus and CD in an equilibrium process between Fe and CD2 plus. We want to know, will the following reaction occur spontaneously at 25 degrees Celsius if the Fe2 plus concentration is 0.60 moles per liter and the CD2 plus concentration is 0.10 moles per liter? Well, in order to solve this problem, the first thing we're going to have to do is we're going to have to determine what's being oxidized and what's being reduced. The oxidation occurs when our cadmium loses 2 electrons to become cadmium 2 plus. The reduction occurs when our Fe2 plus gains 2 electrons to form 2Fe. Now, we are losing 2 moles of electrons in the oxidation process and gaining 2 moles of electrons in the reduction process. Those are the same 2 moles of electrons. They're not different. Same 2 moles of electrons. The 2 moles of electrons that are lost are the 2 moles of electrons that are gained. And therefore, for this process, the value of N, the number of moles of electrons that are transferred, is 2. E naught of the cell is going to be the reduction potential at the cathode, which is in blue, minus the reduction potential at the anode, which is in red. So if we look up those values in the textbook, we get negative 0.44 minus negative 0.40. When we add those up, we see that E naught of the cell is a negative 0.044 volts. Because E naught of the cell is because E naught of the cell is negative, not 0, but negative, we see that the forward reaction is not the reaction that is favored. It's the reverse reaction that's favored. So the reactants are favored over the products. But this is true when we're under the standard state conditions. Well, we're not under the standard state conditions. Standard state conditions would have the concentrations of both of those 2 species at 1 mole per liter. No, we're not under the standard state conditions. We are at a condition of 0.6 moles per liter and 0.01 moles per liter. Therefore, if we take out the equation that we previously developed, plug in the E naught of the cell, plug in the value of N, and plug in the concentrations for our CD2 plus and our Fe2 plus, we would see that E of the cell under these conditions is a positive 0.013 volts. Therefore, what it's telling us, my friends, is that under these conditions, the forward reaction is favored over the reverse reaction, and therefore products are favored over reactants. So under the standard state, this cell would not be working, but under the conditions as prescribed, this cell would be working. It would be producing electricity, and the voltage under these conditions would be 0.013 volts. Because E is greater than 0, as we said, the reaction in the forward direction is spontaneous. And so that's it. I got nothing else to say. Hope you enjoyed the video. Hope you find it helpful. And